So the next topic what we are discussing here is about the field effect transistor. This comes under the module 2. So we shall discuss what is JFET in this class. So what do you mean by FET? FET is a field effect transistor and is a voltage operated device that can be used in amplifier and switching circuits. Field effect transistor is a type of transistor that uses an electric field to control the flow of current in a semiconductor. FET are a device with the three terminals, source, gate and drain. FET control the flow of current by the application of a voltage to the gate, which in turn alters the conductivity between the drain and source. FET are also known as unipolar transistor since they involve single carrier type operation. That is, FET use either electrons or hole as charge carrier in their operation, but not both. The two major categories of FET are JFET and MOSFET. They are again subdivided into two types, P channel and N channel. So first let us discuss what are the difference between the BJT and FET. BJT is a three-terminal semiconductor device. FET is a three-terminal semiconductor device. It has BJT has emitter, base and collector, whereas FET has source, gate and drain. It is a current control device, but FET is a voltage control device. BJT is a bipolar device, FET is a unipolar device. In BJT there are of two types, NPN and PNP. In FET, two types, JFET and MOSFET. So these are the few difference between BJT and FET. Coming into a similarity between FET and BJT, amplifiers, switching device, impedance matching circuit. The differences between these two are FET is a voltage control device, BJT is a current control device. FET have a higher input impedance, BJT have a higher gains. FET are less sensitive to temperature variation and are more easily integrated on IC. FET are generally more static sensitive than BJT. So coming into the classification of FET, in the FET, two types, junction field effect transistor, metal oxide semiconductor, FET. In the junction FET depletion mode, there are of two types, N channel, P channel. In the metal oxide semiconductor FET, again it has two types, depletion, enhancement. In the depletion again two types, N channel, P channel. In the enhancement again two types, N channel, P channel. So next in the FET types, there are two types, N channel and P channel, as we discussed. You can check the similarities here. Here in the N channel JFET, arrow mark is towards the inside, whereas in the P channel JFET, arrow mark is outward. Coming into the construction of JFET, as we know there are two types of JFET, N channel and P channel. The N channel is most widely used. There are three terminal, drain, source are connected to N channel, gate is connected to a P type. So you can look into the diagram here. So you can see N type, N channel. Both the P types are connected to a gate. So this is a depletion region and this is a depletion region, source, drain. So coming into a JFET operation, So JFET can be compared to a water drain system. So you can see the tap here. Assume this is a source. The water which is being flowed is being controlled by a gate. Okay, this is just an example diagram. You can see here the source of the water pressure is accumulation of electrons at the negative pole of the drain source voltage. The drain water is the electron at the positive pole of the applied voltage. The control of water or flow of water is the gate voltage that controls the width of N channel and therefore the flow of charge from the source and drain. So JFET operates in three basic operation conditions. What are those? VGS is 0, VDS is increasing to some positive value. VGS is lesser than 0. If 0 is greater than VGS, VDS at some positive value. It is a voltage control resistor. Coming into a JFET operation, VGS is equal to 0. The three things happens here. VGS is equal to 0. VDS is increasing from 0 to more positive voltage. When we go on increasing the VDS more positive, you can see here this voltage, the depletion region between the P gate and N channel increases as electrons from N channel combines with holes from P gate. Increasing the depletion region decreases the size of N channel, which increases the resistance of N channel. Even though the N channel resistance is increasing, the current ID from the source to drain through the N channel is increasing. This is because VDS is increasing. JFET operation characteristics in pinch-off region. When VGS is 0, VDS is increased, furthermore increased to a positive voltage. Then what happens? Then the depletion zone gets so large that you can see here it has been pinched off the channel. This suggests that the current in the N channel ID would drop to 0, but it does just the opposite. As VDS increases, so does ID. So next is JFET operation characteristics in a saturation region. So at the pinch-off region, any further increase in VGS does not produce any increase in ID. You can see here, once it gets pinch off, further increase does not produce any increase in ID. So ID attains a saturation level or maximum level. It is referred as IDSS. The ohmic value of the channel is maximum. See, look at the diagram now. It is a plot of VDS versus ID. When you go on increasing VDS, ID will also increase. At some point it gets saturated. It doesn't increase if you increase VDS also. That is called as saturation level. Next, JFET operation characteristics. Let us discuss about the characteristics now. When VGS becomes more negative, the depletion region will also increase. Okay, when it is more negative, depletion region will also increase. So JFET experiences a pinch off at lower voltage VP. When ID decreases, even though VDS is increased, eventually ID reaches to 0 amp. VGS at this point is called VP or VGS. Also note that higher the level of VDS, the JFET reaches breakdown situation. ID increases uncontrollably if VDS is greater than VDS max. So this is what they are saying here. Look at the diagram. You can see the plot of VDS versus ID here with keeping VGS constant value. For different constant value of VG, yes, we are noting down the VDS and ID. So we will note down it and we will plot it such that we will get a ohmic region as well as the saturation region. Once it saturation region, when it attains saturation region is when it reaches the pinch off condition. So JFET operation, voltage control resistor. Region to the left of the pinch off point is called the ohmic region. JFET can be used as a variable resistor where VGS control the drain source resistance. As VGS becomes more negative, the resistance RD increases. RD is equal to R0 divided by 1 minus VGS by VP whole square. So you need to know what is ohmic region here. The left part after the pinch off. So that region is called as ohmic region. So next is P channel JFET. Here you can see here P will be the channel here, so it behaves same as the N channel JFET. Expect the voltage polarity and current directions are reversed here. Okay, so P channel JFET characteristics. VGS increases more positively, depletion region increases, ID decreases, eventually ID is equal to 0 R. Also note that higher level of VDS, the JFET reaches a breakdown situation. ID increases uncontrollably if VDS is greater than VDS max. So you can see how it is been increasing. Next, N channel JFET symbol. So arrow mark is towards the inside. So JFET transfer characteristics. The JFET transfer characteristics of input to output is not as straightforward in a JFET as it is in the BJT. Okay, in BJT, beta indicates the relationship between IB input and the output. In JFET, the relationship of VGS input and ID output is little more complicated. So ID is given by IDSS into 1 minus VGS by VP whole square. So this is a transfer curve of JFET. So here you can observe the transfer curve. So it is a plot of VDS versus ID with a different value of VGS. By this we understood the working of JFET, P channel and N channel. By this I will end this video.